Hello everyone, myself Praveen Kumar Sahu, and today I am going to discuss regarding the particular integral. I have already discussed that an equation of this kind is said to be second order differential equation, and the solution of this kind of differential equation is given by two parts. One is the complementary function and the other is particular integral. If here r is equals to 0, where r is what? Some function of x. It can be sin x, it can be cos x, it can be a polynomial, it can be anything. Okay, so if r is equals to 0, then we only need to find complementary function as the solution of this differential equation. And if we are having some non-zero value of r, then we will be finding complementary function, and along with that we will be finding the particular integral, and the sum of the complementary function and the particular integral will give me the complete solution of this equation. So let us see some rules how to find the particular integral for different forms of r which is a function of x. So let us begin.
For particular integral, rule number 1 is that if r is equals to some exponential function of ax, suppose e to the power ax, then particular integral is given as 1 by f of d e to the power ax is equals to 1 by f of a e to the power ax. So this is how we define particular integral if our r is equals to some exponential function of x. Okay, let us try to understand this by solving a problem. For example, we have suppose a problem: solve d square y by dx square plus 6 dy by dx plus 9y is equals to 5 e to the power 3x. So this is the equation we are having. We can find your complementary function as well as particular integral. Since we are having non-zero value of r, so we will find at first complementary function here, and then we will find particular integral. So since we know already how to find the complementary function, we will directly find their particular integral. So let us find directly the particular integral. So here particular integral pi is equals to what? 1 by f of d, and here function is what? 5 e to the power 3x. So this can be further written as, so what is this f of d? I think you know already this. That is, here we can write what? D square plus 6d plus 9. Okay, and here we have 5 e to the power 3x. So this can be further written as, now as you can see here I have written what? F of a. F of d is equals to what? 1 by f of a for exponential function. So what is the value of a here? 3. I will substitute the value of 3 here. Okay, and let us see what we are getting. So 5 is a constant, I can take it outside in this way. 1 by, here it is 3 square plus 6 into 3 plus 9 e to the power 3x. So which is equals to what? 5 e to the power 3x divided by, so here we have 9 plus 6 3 is 18 plus 9, so which is equals to 36. So I can write 5 by 36 e to the power 3x. So this is how we have found particular integral here. So therefore Here particular integral is what? 5 by 36 e to the power 3x. So this is the value of the particular integral for this problem. I hope all of you have understood this. Okay, now this was a very simple case, but sometimes what happens, we get the denominator part equals to 0. If we get the denominator part, means this part equals to 0. In that case, we have to apply something different. So if we get our denominator part 0, that is f of a is equals to 0, then what we have to do? We'll simply write in normal way only e to the power ax, and then we'll simply do differentiation. So we will differentiate this part. Okay, since we have differentiated this f of a once, so we'll multiply it with x and e to the power ax. So this is how we find the particular integral if we get the denominator part f of a is equals to 0. If suppose again we are getting f dash of a is equals to 0, in that case again what we do? We do the same thing, that is f of d e to the power ax is equals to x square 1 by f double differentiation of f of a e to the power ax. We will differentiate it twice if we get f dash of a equals to 0. So the many times we differentiate, the many times we multiply here x. Here we have differentiated twice, so we have put x square. If we differentiate it thrice, then we put here x cube, and so on. So the target is that this denominator part should not be equals to 0. If we get it 0, we differentiate it and we multiply here x as many times. So let us try to understand this with the help of an example. For example, solve d cube plus twice d square minus d minus 2 whole thing into y is equal to e to the power x. So here f of d is this. So let us find the particular integral. So p dot I will be equals to 1 by f of d e to the power x. So here we can see the value of a is 1, and if we substitute the value of 1 in this f of d, then we will be getting 0. So what we do, we differentiate this again. We will multiply here x and we will differentiate this. It will be thrice d square plus 4d minus 1 e to the power x. Now if you substitute the value of 1 here, it will be how much? Let us see. X e to the power x 3 1 square plus 4 into 1 minus 1. So we are getting what? 6. So x e to the power x by 6. So this is the value of the particular integral we are getting here. Let us see another problem. Suppose we have this problem, solve d square y by dx square minus 6 dy by dx plus 9y is equals to e to the power 3x. So here we can see that particular integral is what? Is equals to 1 by f of d e to the power 3x, which is equals to 1 by f of d is what here? D square minus 6d plus 9 e to the power 3x. So here value of a is 3. If we substitute here 3, we can see that we are getting the denominator part to be 0. That is, if you substitute here 3, it will be 9 minus 18 plus 9. So it is coming to be 0. So what we have to do then? We will differentiate this. So we'll multiply it here x, and you will simply differentiate this. It will be twice d minus 6 e to the power 3x. Again you substitute the value of 3 here. You can see it is again 0. 2 3 just 6 minus 6, it is 0. So again we will differentiate this. We multiply it x here, that is it will become x square minus 2 e to the power 3x. So this is the particular integral for this problem. So this is what we have seen here, that if denominator part becomes 0, we have to differentiate it. Okay, and along with that we have to multiply x in the numerator. So this is what we have learned about the first rule. Let's try to solve these problems which I am giving here. Number 1, solve d square y by dx square minus 6 dy by dx plus 9y is equals to 6 e to the power plus 7 e to the power minus 2x minus log 2. Let's try to solve this problem. It is interesting problem. I will just give a hint here that nothing means e to the power 0x. So here you have to imagine that here is e to the power 0x. Log 2 is a constant, okay? It has nothing to do. It will remain as such only. So please try to solve this problem. I am giving another problem too. D minus 2 into d plus 1 whole thing square y is equals to e to the power 2x plus e to the power x. Okay, so these are the two problems. Let's try to solve this. Answer to problem number 1 is thrice x square e to the power thrice x plus 7 by 25 e to the power minus 2x minus 1 by 9 log 2. So this is the solution for the particular integral. This is the answer number 1, and for answer 2, x by 9 e to the power twice x minus e to the power x by 4. So these are the two solutions of the first two questions. So please try to solve this, and if you have any problem you can just tell me through WhatsApp or any means. Okay, thank you.